Welcome to today's session. Subject is a smart grid. Today's topic is Introduction to Smart Grid. Myself, R. Radhamani, ASP, Triple E. Electric grid. An electric grid is a network of synchronized power providers and consumers that are connected by transmission and distribution lines and operated by one or more control centers. So the electrical energy is generated in the generating station. Then the generated energy is transmitted and that is a transmit to the consumers through the two networks noted as a transmission lines, and also another one is a distribution system. So transmission system and distribution system. So this is the electric power generation have the three stages. One is generating station, another one is a transmission system, and third one is the distribution system. So but with the help of these two systems only, the generated electrical energy will be provided to the consumers provided to the consumers. Here, this is the generating station is a power provider, and the customer is the end users. So in between these two networks, transmission and consumer, this network is used to transmit the energy. So the grid is nothing but a network of synchronized power providers. There is a generating station and the consumers, that is the end users. So that are connected by the transmission and distribution lines. So this is the transmission and distribution lines. So and also we need some control schemes to control the system so that and operated by the one or more control centers. So this is the general definition of your electric grid. So these stages are differentiated with the help of the different colors. The red color indicates the generating station, and blue indicates the transmission system, and green color indicates the distribution system, and the black color indicates the customers. So these are all the sections available in the power generation. So the first one is the generation. So there is a various generating power plants are available. So thermal power plant, hydro power plant, nuclear power plant, and also the renewable energy based power plants. So with the help of this renewable energy sources, then the power can be generated. So next one is the transmission. So transmission is have a two type of transmission system. So one is a high voltage AC transmission system, and another one is a high voltage DC transmission system. So next one is a distribution. So that is the similar to your transmission. The distribution also two type. One is AC distribution, and another one is a DC distribution. That is alternating current, and another one is a DC is a direct current. Then the final is the consumers. So consumers also subcategorized into three. One is industrial consumers, commercial consumers, and the domestic consumers. So this is a vertical structure of your system. So this slide shows the history of power. So first, the Thomas Edison is the father of direct current distribution. After that, Nicholas Tesla find the alternating current distribution. So due to the lower cost and higher efficiency, the AC distribution become a more commercialized when compared to the direct current distribution. Normally, the alternating current distributions are used for long distance, and the direct current distributions are used for short distance. When compared to this DC distribution, so AC distributions is a more commercialized, and this is the evolution of in Indian national grids. So generally, we have the five regions, namely northern, eastern, western, northeastern, and southern regions. So in this early 60s, the state grids were interconnected to form a regional grids. So totally we have the five regions. After that, in October 1991, the northeastern and eastern grids were connected. So because to achieve the one nation, one grid, and one frequency system. So after that, in March 2003, the western and eastern, northeastern were interconnected. And then August 2006, east grids and the north is interconnected. So totally the four regions grids are synchronized together, and it is connected to the generalized grid operating at one frequency. So finally, in 31st December 2013, The remaining one region, that is the southern regions, were connected to the central grid. So after that, we are achieving that one nation, one grid, one frequency system. So this is a power scenario. Various resources we are using to generate the electrical energy. So that resources are the coal, renewable, hydro, nuclear, diesel, and gas. So major portions we are using is the coal. The installed capacity of coal is an 194.4 gigawatt, and the next largest total installed capacity which they have is the renewable energy sources. There is a 57.258 gigawatt. So you know this, the renewable energy sources have the number of sources. So solar, wind, biomass, and small hydro. So this figure shows the installed capacity of each renewable energy sources. So next is the the definition for grid. Grid is nothing but that is a network which connects the power providers and utilizes through the transmission and distribution lines. So we make this grid as a smart. So the digital technologies that allows for two-way communication between the utility and the consumers, and the sensing along the transmission lines is what makes the grid smart. But if it is an electrical conventional grid, there is a one-way communication. So that this means that only the informations from the power providers will be transmitted to the consumers, and there is no um communication between the consumers and the power providers. So there is no information is transferred from consumers to the power providers. But in case of smart grid, so there is a two-way communication is possible. So because in this case, in nowadays, you are using the smartphones. So we know the meaning for smart, isn't it? So with the help of this, you can you can manage your personal banking from your home computer or your mobile phone itself. So imagine that if you are managing your electricity in the similar way. So if it is in this case of normal conventional electric grid, so the consumer should wait for a time to get the monthly statement, isn't it? So if you are having the smart grid, if you are make the grid as a smart, so the consumers will not no longer have to wait for the monthly statement. So easily they can know how much energy he is using and what is the cost of the cost of electricity, and each and every information he knows at a time. So there is no need he or she has to wait for the electricity bill. And by so if you are using this smart meters in our home, so automatically they can easily calculate the amount, or easily they can know how much electricity they are using, and then when they use it, and similarly what is the cost of that consumption. So how much they are consumed, that is how much they are used. So they know all the information. So with the help of these information, they can control the electricity usage. So that will help them to reduce their electricity bill. Okay. So smart grid has the potential to help us to save the money by helping you to manage your electricity use. Because if you know this, so this much of energy is used means, so with the help of this information, so we can calculate the tariff, and also we can reduce the usage of electricity. So when you are reducing the usage means automatically it will reduce the electricity bill. So that is the thing. So smart grid is helpful to us to save the money. And these are some of the key requirement behind the modernization of the conventional grid. So the first one is to boost the reliability, effectiveness, and the security of the power grid. And the next key point is that to facilitate this decentralized bulk power generation, generating plants for two-way transmission. Third one is to make the power consumption to be flexible. And the final one is to create the more green collar energy jobs related to renewable energy sources. So these are all the some requirements why we are modernizing the conventional grid. So the modernized conventional grid is known as a smart grid. So what are the expectations from the smart grid? So, if you are installing one smart grid system, means so what are our expectations? So, definitely the smart grid should be a more secure one, and similarly, it should be a more efficient, and it should be a more reliable, and similarly, the smart grid should be a more environmental friendly, and it should be a very safer one, and also it should be a more cost effective. So these are the expectations of smart grid. So this is a definition for smart grid. So in this conventional grid is added with the ICTs. ICT is nothing but advanced information communication technologies. So if you are adding this information communication technologies with your conventional grid, so then the system will become the smart grid. So the smart grid can be defined as it is an electric network that can smartly integrate all the clients connected to it in order to efficiently deliver sustainable, cost effective, and secure power supplies. So these are all the duties of smart grid. More efficient transmission of electricity. So the smart grid should transmit the electricity in more efficient manner, and quick restoration of electricity after power disturbances. So if there is any power disturbances occurred in the network, so definitely it should be quickly restored. So quickly solved. So that is the one of the duty of our smart grid, and reduced operating and management cost. So it should reduce the operation and management cost for utilities, and ultimate low power cost for the consumers. So automatically in cost point of view, so it will help to reduce the cost. And also another one duty of smart grid is reduced the peak demand and increasing integration of large scale renewable energy systems, and the better integration of customer owner power generation systems including renewable energy systems. And the final one is the improved security. So in this case, if it is a normal conventional grid, so the integration of renewable energy systems to the grid is one of the challenge. So but in case of smart grid, so it will help to incorporate, and also it will help to um, help the consumers to deals with the grid, to operate with the grids. So that means that if your consumers have their own power generating stations in their home itself, so by using the renewable energy sources, so automatically this energy sources will connected to our grid. So if you are having the more amount of energy, so that will be fed back to our grid. So that is the meaning that better integration of consumer owner power generation system, including to the renewable energy system. These are the some features of smart grid. So smart grid should be a self-healing one. This is the major feature of your smart grid. But in case of conventional grid means, so we need some manpower to replace that fault. But if it is a smart grid, so it should be a self-healing one. So and another one is to motivate the customers to actively participate in the operation of the grid. So that means that uh, integration of our smart grid system to the grid, restrict attack or hacking. So because if it is a smart grid, it always deals with the data communication in the internets. So we using this ICT, this information and communication technology. So it always deals with the internet. So that should be more securable one. So as a smart grid, so it should resist the attack or hacking of the system. So that is another one feature of the smart grid, and provide higher quality power. So definitely the power quality should be high, run more efficiently, and also they enable higher penetration of intermittent power generation resources. And the final feature is the enable electricity markets to flourish. So these are all the some features of our smart grid. So, in this class, we discussed about what is meant by conventional grid and what are the components we are used in the power system. And similarly, okay, well, there is a history of power, and there is evolution of grid, and there is what is meant by smart grid, and what are the expectations and what are the features of smart grid. Thank you.